All right, so we're given this rational function, and we want to graph it, which means we need to factor it. So in the numerator, I'm going to rewrite that as x plus 5 squared, because that's what it means when you take x plus 5 and multiply it by x plus 5. It means squared. That's important because that means that 0 will bounce. In the denominator, I have x squared plus 9x plus 20, which will factor as x plus 5 times x plus 4. So what I said a moment ago actually isn't true. Notice I have an x plus 5 in the top and an x plus 5 in the bottom, which means this function will simplify. I'll take out 1 power of x plus 5. It will leave me with a power of x plus 5 in the top still and an x plus 4 in the bottom. But I have to remind myself that x cannot equal negative 5. X cannot equal negative 5 because I have a whole. I have a power of x plus 5 in the top and the bottom. But what do you do with a whole? You take it out. Once you take out a whole, the function is going to look exactly the same as what's left. It's just going to have a whole at that single x value, which is actually pretty important for us for sketching this graph. If I want to sketch this graph, I know I have a y-intercept, I have a horizontal asymptote at y equals 1 because I have an x over an x. I have a degree 1 in the top and a degree 1 in the bottom, no coefficients, so horizontal asymptote at y equals 1. So there's a good start. X plus 4 in the bottom tells me I have a vertical asymptote at x equals negative 4. So 1, 2, 3, 4. We will dash that in right there. Okay, and then we said x cannot equal negative 5 because there is a hole at negative 5. But think about what I said a moment ago. I said that this graph, the original function, will look exactly like this function in the box. It will just have a hole at negative 5. But think about what's important about where this function is at the x value of negative 5. This function in the box, negative 5 would be an x-intercept, which means that my hole is actually on the x-axis right here, which means my graph is actually going to cross through the x-axis there, which is super important. It's very subtle, but it's very, very, very important for us to understand that, because that then means that this graph has to look like that. It doesn't technically have an x-intercept. It has a hole there, but it has to cross through like that, otherwise this behavior will not work. Then on the other side of the asymptote, I've got to be up like that. You could find your y-intercept by plugging in 0 for x, and you'd be left with 5 over 4. So my y-intercept there is at 5/4. And I think that is all we're going to do for this function.